Welcome to this lesson on the introduction to blockchain development using Ethereum, presented by Coding Bootcamps. First and second generation blockchains. Just a recap of information about our instructor and a recap about some courses you may want to take as well, and our introduction to Ethereum. So, blockchain progress. So all blockchains can record monetary transactions. So blockchains, at their heart, blockchains are ledgers. The monetary transactions can be cryptocurrencies, or even in some cases fiat currencies such as a US dollar. Bitcoin only transfers ownership of Bitcoin. So the Bitcoin network only manages its native token. Second generation blockchains track not only their native token, but also any kind of asset. So it can be financial instruments or information assets or hard assets such as precious metals, gold, real estate. Blockchains can transact the recording of such items as deeds, marriage and death registrations, elections, medical records, supply chains, and many more. Blockchain is a powerful asset tracking system. Another key aspect of second generation blockchains is they take computing action on transactions. So you can actually write applications that run on second generation blockchains. An event-driven blockchain adds many possibilities to the use cases, and rules can be written for the blockchain to take action on transactions. If that sounds like executing the terms of an agreement or a contract, you would be right. So these rules are computer programs called smart contracts. Smart contracts are deployed to the blockchain and run when called by blockchain events and or blockchain transactions. So smart contracts are nothing more than a computer program that runs on a blockchain. In spite of their names, smart contracts are not really legal contracts. They can enforce a legal agreement and they can carry out the terms of a contract. However, they are, again, computer programs that execute on a blockchain and enforce business rules, complete certain tasks, take action on transactions. The blockchain is a record keeper for the business tasks being completed. Just as any other blockchain data, smart contracts are immutable on the blockchain, so they can never be changed once deployed. If we want to deploy a new version of the smart contract, we must deploy a new version, and then that contract would be the updated one that would always run. The previous version is all data on the blockchain is immutable. A smart contract is updated when applying a new version of the smart contract. So you get another address for the new smart contract. With some exceptions, a blockchain is a single running ledger on independent and separate nodes. Well, Hyperledger is a good example of a blockchain where there are multiple ledgers, but in Ethereum and Bitcoin, there is a single ledger. The fact that there are single or multiple ledgers does not indicate whether a blockchain is second generation or first generation. Operators of the individual nodes are called miners. It just turns out that with Ethereum, all nodes are peers. There's only one node type, one ledger in Ethereum. A ledger must be synchronized, therefore the nodes must agree. So there is this concept of a consensus algorithm in Ethereum. Pending transactions are continually arriving on the blockchain, and these transactions must be verified and added to the blockchains. So primarily, this is what miners do. Miners validate transactions. When pending transactions come in, they create what's called a proposed block. As the pending transactions are verified, the proposed block fills up, and it soon becomes time for the block to be added to the blockchain. There is a certain continuous time interval where the transactions on the blockchain fill up the block. The miners complete their additions to the proposed block and they run a consensus algorithm. The idea here is to keep the ledger completely synchronized. So if you and I and a few others were maintaining what was supposed to be a single document and we were updating it and adding to it and editing it, the contents on that document would drift. And the idea here is to resynchronize it on a regular interval. So once a miner wins a competition, which is currently proof of work, the block is added to the blockchain, and then that new block is relayed to all the other nodes, thereby synchronizing the blockchain. And once the synchronization is complete, the cycle begins again. There are several types of consensus algorithms. Proof of work is currently what Ethereum is using. However, Ethereum 2 is moving toward something called proof of stake. Proof of work involves running a computer program that looks to solve a complicated puzzle. It's actually searching for a nonce. Nonce is a random number. The nonce is identified, and it becomes part of. Once the nonce is identified, it becomes a part of a hash for the next block. The proof of work validates whether a miner is contributing time, effort, electricity to the blockchain network. And once miners add a new block, they're rewarded in that blockchain's native token, which in the case of Ethereum would be Ether. Proof of work is very expensive, consumes a lot of electricity, as it requires an immense amount of computing power. And again, there all are alternatives to proof of work. Ethereum, with Ethereum 2, is planning to move toward proof of stake. As a matter of fact, one of the Ethereum test networks is already using proof of stake. Some alternatives listed below, you can see here to the proof of work consensus algorithm. Proof of burn, proof of capacity, proof of elapsed time, and there's many more. So blockchains support public transparency, and it is 100% validatable by the community and anybody watching the transactions. Since a blockchain is distributed, miners manage each node, and a certain level of security is bundled with support for the community and transparency. Blockchain provides a clear view of custody, chains of custody for assets, making it a perfect tool to secure and manage supply chains. Some of the other benefits are anonymity, cryptography, the transaction transparency of the blockchain enable a trustless environment. So it's done right in the open, and everybody can see the updated ledgers, who was paid and when they were paid. The emergence of smart contracts now enables blockchain applications. We've already discussed this. Smart contracts can perform important tasks on the blockchain. Some of the disadvantages to a blockchain are there is a new skill set that the community has to learn. Blockchains are slower than centralized database applications. They consume a lot of energy. Blockchain networks cannot process the amount of transactions per second as centralized applications. So for instance, Ethereum can do anywhere from 15 to maybe 25 transactions per second. If you compare that to the Visa network, which says about 70,000 transactions per second, there's quite a difference there. So is a blockchain required? Not always. So the benefits of the blockchain are unique to its architecture. However, your solution may benefit from a blockchain, maybe not. Quite often a central database solution can also provide the solution you need. So here are some of the benefits that a blockchain delivers. And if your application needs these, like public transparency, high failure tolerance, high degree of transaction demand, trustless environment, low transaction fees. If your application needs this, then a blockchain may be a solution for you. Ethereum, so this is what we discussed, Ethereum and second generation blockchains, blockchain consensus, smart contracts, how smart contracts run, and the Ethereum and blockchain advantages and disadvantages. Please complete the assessment. For additional resources, please consult your training materials. And for more training, please also consult your training materials. In our next session, we'll talk about Ethereum and cryptography. Thank you.